Hey guys, welcome to Unit 2, Notes 1, Systems of Equations. And our learning target today is I can solve systems of equations by graphing. So let's start here with a systems of equation warm-up. It says graph the two linear equations on the same coordinate plane. Okay, so our first one I'm going to graph in blue, and that is going to start with a y-intercept of -5. And then we have a slope of 3. Remember, it's not just 3, it's 3 over 1. So we're going to go up 3 over 1, up 3 over 1, up 3 over 1, up 3 and over 1. Really important when we're graphing systems is that we fill the entire graph with points. And so we also want to think about our slope as -3 over -1. So go down 3 and to the left 1. Because you never know that that very last point that you graph might be there, the important piece. All right, our next one, I'm going to graph in red, has a y-intercept of 2 and a slope of -1 over 2. So we're going to go down 1 to the right 2, and you're going to fill the graph with that. And then we're also going to think -1 over 2 is the same thing as 1 over -2. So we're going to go up 1 and -2, up 1, -2, up 1, -2, up 1, -2. All right, so we have graphed our two lines. So just write down everything you notice about the two lines. Just think about, what do you know about these two lines? What is interesting about these two lines? How do they interact with each other? All right, so let's graph our second problem here. And we're going to graph our first equation in blue. So we're going to be at -6, and then we're going to go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and we can't go any further either direction. All right, and then our next equation's not in slope-intercept form, so y equals mx plus b. So let's move it there. -6x to both sides. So we have -2y equals -6x plus 12. We got to get rid of that -2. Remember, you're dividing each and every term by -2. So y equals 3x minus 6. We're going to graph that. We have our -6 intercept point, up 3 over 1, up 3 over 1, up 3 over 1, and we have now graphed our second line. Take a look at that. Think about, well, how do those interact? What do you notice about the equations? And we'll chat about those. So let's talk about, well, what is a system of linear equations? It's a system is a set of two or more linear equations. And the solution to a system is the point xy where the two lines cross. And we actually have that represented here. We actually have three types of solutions. The first one we just talked about, one solution where you have a point of intersection. We also have no solution where you have parallel lines that occur. Notice the answer is no solution, not the answer is parallel lines. The answer is no solution. And then we have infinitely many solutions where it ends up being the same lines. All right, so our steps to graph this is, first you're going to graph the first line, then you're going to graph the second line, and the last part is find the ordered pair where they intersect. If they're parallel, they have no solution. If they end up being the same line, they have infinitely many solutions. Pause the video if you need to get all this information down. All right, so solve by graphing. Let's go ahead and graph these two equations. My first one I'm going to graph in red has a y-intercept of 8. And our slope is -x. Really, we're thinking our slope is -1. So we are going to go ahead and fill the entire graph with new points and graph our line. Our next one has a y-intercept of -7 and a slope of 4 over 1. 4 over 1, and then 1, 2, 3, 4 over 1, and then the next point will take us off our graph. All right, so we followed the first two steps. We graphed the first one, we graphed the second one, and the third step says find the point where they intersect. Our point should be written in an ordered pair, x, y. Remember, x tells us how many we are going to the left or to the right, and I see that we go to the right 3, and then we go up 5. So both of our numbers are positive. Let's just check with our answer here. And we get 3, 5. Great. Now with number 4, I want you to notice that your worksheet is missing that negative in the second equation. Please put that negative in the second equation. Otherwise, it's not going to work out for our solution. I want you guys to graph both of these equations and talk about their solution. And we will look at that when you guys come back to class. All right. We have a word problem here. Monica and Max Gordon each want to buy a scooter. Monica has already saved $25 and plans to save $5 per week until she can buy the scooter. Max has $16 and plans to save $8 per week. So let's write some linear equations for these. Let's start with Monica. We have y, that's going to represent our total. So our total equals, she is saving $5 per week. So X is going to represent weeks. So weeks and total. But she already has $25, so we need to add that in. Let's talk about Max. Max, he has a total of $8 per week plus his original $16. So to graph that, let's count each of our y lines worth 2. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. 2, 4, 6, 8, 40. Okay, and each of our weeks lines is going to represent 1. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that gives us 10. 1, 2, 3, 4, 5, 15. And our last one is going to be 20. All right, so I've given you the tools to be able to do this. I've given you the equations. We've set up the graph together. I want you to graph the two lines and then figure out in how many weeks will Monica and Max have the same amount of money saved? And then how much money will each person have at that point? When you guys come back, we will talk about 6 and 7 together. I feel that you guys can do those on your own, so give it a try, and we will talk to you guys then.